Welcome, ladies and gentlemen. Without wasting time, let's get to it. The first question, they want us to expand 1 plus 3x all to the power 6 in ascending powers of x up to and including the term x to the power of 2. Okay, so guys, I'm sure we can all see that here we're going to use the binomial theorem because I have two terms in the brackets, so it's bi. And I have to use the binomial theorem. Remember, the binomial theorem says, I'm going to say, okay, I have 6 to the power, choose 0, right? And then here I'm going to have 1 to the power, the difference between these two, which is basically 6. And then I have 3x to the power, that one. That is the first term. But this will just give me 1. So I'm looking up to where I'm going to get x to the power 2. So we keep on going. We're going to say plus. Now this increases to be 1, but the top doesn't change. So it's basically the 6. Now we're going to choose 1. So here is going to be 1. The difference between 6 and 1 is 5. And then 3x to the power of 1. If you observe, the bottom always goes to the next second term. The bottom always goes to the second term. Even here, the bottom is there. And then now, I'm sure you guessed well, that is going to be 6 choose 2 now, right? And then it's going to be 1. The difference is now 4 between 6 and 2. And then you have 3x to the power of 2. Now, this one is going to give us the x squared. So I'm going to stop there, ladies and gentlemen. And then let's see from there. Let's simplify this. 6 choose 0 is 1. 1 to the power 6 is 1. 3x to the power 0 is 1. Anything to the power 0 is 1. 6 choose 1 is going to give us 6. And then 1 to the power 5 is going to be 1. And then here we're going to have 3x. And then 6 choose 2, that will give us 15. And then here we have 1 to the power 4, which is just 1. And then here you're going to have 3x multiplied by 3x because of the square, which give us 9x squared. So dot 9x squared. All right. And then we can see that 1 times 1 times 1 is 1. And then 6 times 1 times 3x give us 18x. And then this times that times that. Let's check quickly on a calculator. That give us 135 x squared. All right. Awesome. So ladies and gentlemen, I'm just going to move my microphone like this. Awesome. And then that's it for this question, ladies and gentlemen. Right. Okay, and I advise you to show 3 dots to show that this will keep on going like this. So just show 3 dots there. Awesome. And then now we can go to the next part of the question paper. The next part, they say hence. Okay. Remember, if a question says hence, they mean use your answer above. Right. So, because they said hence, I'm going to use, I know that we have to use that. No? Awesome. Let me just write it here quickly. 1 plus 18, 18x plus 135 x squared. Okay, sharp. So they say, hence find the coefficient of x squared in this expression. Okay, let's write the expression down. This expression is 1 minus 7x plus x squared. And then we're going to have, remember this guy simplifies to this, the first three terms of this expression are there. So I'm going to input them here. Don't forget that if the questions say hence, they mean use the answer you got above, basically, right, to help you maneuver the next question. So this is 135 x squared. Then I can show three dots that this continues like that. But obviously, the next powers are going to be to the power 6, to the power 7, which will not be, to the power 6, to the power 5, to the power 4, to the power 3. That are not going to be helpful, ladies and gentlemen. So now I'm going to group them in the order of which they're going to give me x squared. You can see that this one and that one are going to give me x squared. And then this one and that one, when you multiply, you're gonna somehow end up with an x squared, then this one and that one, right? Now we can multiply. So we're going to have 135 x squared, which is this one multiplied by that one. And then minus 7x times 18x give us a minus 126 x squared. And then this times that gives you plus x squared. And then we get this minus that is 9 plus 1. So we get 10 x squared. Therefore, remember they need the coefficient of x squared. So you have to write the coefficient of x squared equals to 10. And then that's it with this question. Let's get to the next one. Let's get to the next one. So on the next question, they say, sorry about that, ladies and gentlemen. I think I caught some cold, but yeah, that's fine. So they say a line has the equation this. Let me write it down here. Y equals to 2cx plus 3. And a curve has the equation y equals to cx squared plus 3x minus c, where c is a constant. Showing all necessary calculations, determine which of the following statement is correct, right? Awesome. So the line and curve intersect only for a particular set values of c. The line and the curve intersect for all values of c. The line and the curve do not intersect for any values of c. So obviously, ladies and gentlemen, if I hear the word intersection, what comes to my mind is to equate the two equations because they are intersecting. Okay. So I have 2cx plus 3 equals to cx squared plus 3x minus c. All right. And then if I need to get the nature of the solutions, if I'm going to have one intersection, many intersections, or no intersection at all, I have to do nature of the roots, right? So this question, we know that we're going to use b squared minus 4ac, right? So we need to write it in a standard form first. We need to write it in form of ax squared plus bx plus c, so that it's easier to extract a, b, and c, and then do the discriminant. Awesome. So now let's check. I'm going to take everything to the left, to the right. So we're going to have cx squared plus 3x. I'm going to group with this one, so which becomes minus 2cx. And then this one is there, minus c, and then this one will become minus 3. So now we can easily see that, okay, cx squared. Here I'm going to take x out. So we're going to be left with plus 3 minus 2cx, right? Then minus c minus 3. Now, ladies and gentlemen, I'm sure we can all see that this will be our A, this will be our B, and this will be our C. All right, now we can substitute into the discriminant to see the value of what, to see which part it satisfies. Ne? Sure. So you have 3 minus 2c, then there's a square. Okay, let's write b squared minus 4ac here. Then I can show delta. Ne? This is the discriminant. Then you have minus 4, your AC, and then your C is minus C minus 3, right? Minus C minus 3. And then we need to simplify this. Remember, if you have this, is going to be 3 times 3 is 9. And then you're going to have this times that times that. So 3 times negative 2C times 2. That give us, let's see, minus 12C. Then minus 2C times minus 2C. That give us plus 4C squared. Then here you can see you have minus 4C times negative C. That gives you plus 4C squared. Then negative 4C times negative 3 gives you plus 12C. All right. Then I'm sure we can see that this guy and that guy are going to cancel since they are like term of equal values but opposite signs, right? And then we're going to get 9 plus 8C squared. These are two alike terms. Okay, I prefer to have the C squared on front plus 9, right? And ladies and gentlemen, we can see that this is always going to be greater than 0. No matter what value of C you put here, this thing will always be bigger than 0, ladies and gentlemen. Right? It will always be positive because you're adding a 9. A square is also always positive, and this is already a positive. So the answer will always be a positive for C elements of real. Right? Now let's go back up and see which part we're going to take. A, the line and the curve intersect only for a particular set values of x. That's not true. This is true for all values of x. So the correct answer is B, ladies and gentlemen. You see, the line and the curve intersect for all values of C, as long as C is a real number. Right, so the option you're going to say therefore option B, right? Then finito. Now let's go to the next part of this paper. All right. So the next part, let me do this. Okay. So we're looking for the next part. Okay. So the next part, they say, the diagram shows a cubical closed container made of a thin elastic material which is filled with water and frozen. During the filling process, obviously this figure is a cube, right? Okay. During the freezing process, the length x of each edge of the container increases at a constant rate of 0.01 centimeter per minute. Obviously, this is x, right? And then this is time. So here they give us dx over dt. Remember, centimeter is for x. This is for time. And then they give us a rate. So we have the derivative of x with respect to time. The rate at which the length is changing. They say it's basically 0.01. Right. And then they want us to, they say the volume of the container at time t is V centimeter cubed. Okay, that one we know. That volume is always measured in centimeter cubes. And then they say find the rate of increase of volume. Okay, when x is 20. So basically they're looking for dV over dt. Right. We're looking for the rate of increase of volume. So the rate at which the volume is increasing. So guys, here I use this method called the 4D boxes. Ne? So you just put 4Ds here, 4Ds, and then you always going, the first part of this fraction is what you already have. So you have dx over dt, you know the value, so you know that it must be there in the equation. And then the next thing is, okay, here you have t, and then here you have t. So the t is sorted. But on top, you need to have dv that side, right? So this will be dv. And then this dx must cancel. So this dx will cancel with this one. So we still have dv over dt, which is this. So this is the breakdown or the chain rule. This is the chain rule of this one, right? Sharp. So just use the 4-box method. It's easier, ladies and gentlemen. So from here, I'm going to do this. This one I already have. So I'm worried about dv over. I'm worried about dv over dx, right? Before I can substitute there. Okay, so let's see. Is there a formula that relates the volume and the length? Yes, there's a volume formula that relates the two, right? So you're going to say, okay, but volume, we know that is going to be x cubed because the figure is a cube. So it's x times x times x, which is x cubed. And then now volume is the subject of the formula. We can easily differentiate here, right? So dv over dx is the same as 3x squared, right? But we were told that the value of x is 20. So we're going to say 20 squared, which give us 20 squared is 400 times 400 times what? Times 3. That give us 1,200. All right. Awesome. And then now let's see. Now we can go back and substitute there. Right, we have everything now. We can say, therefore, dv over dt is equals to, remember, the x over dt is 0.01. So this is 0.01 times 1,200. And that should give you, let's check on a calculator. That should give you 12 centimeter cubed per, what was the time used? They were using minutes, so per minute. Remember, volume is cubes, so you have to say centimeter cubes per minute, which is the time. And that's finito. Let's go to the next question. The next question. Okay, let's check this. Sure. So on the next question, they say the transformation R denotes reflection in the x-axis. Remember, reflection in the x-axis, we make y negative, right? And, or you can say make f of x negative. That's what it means, right? And the transformation T denotes, and the transformation T denotes translation of 3 units to the right. Remember, if it's positive, means right, to the right. And then here, it's 1 unit down. 1 unit down. Okay, awesome. That shouldn't be an issue. Find the equation of G of the curve with the equation after it has been transformed by the sequence of transformations R followed by T. So we do R first. So what happens is we're going to have to reflect this in the what? In the y-axis. So we're going to have y is equals to, remember, y was this. So we have negative x squared. This is the reflection in the what? in the x-axis. You just made the y negative. Do you see it? Awesome. But you are going to, here you can show that r creates this, and then now you can show that, okay, after r, we're going to do t, which t will give us y equals to minus. Remember, we're moving 3 units to the right. So 3 units to the right, we subtract on x. So it's going to be x minus 3 units to the right, right? And then we're moving units down. So 1 unit down there. And that is the full transformation, ladies and gentlemen. Let's go to the next one. The next one, they say find the equation of h. Or actually here, let's do this, guys. Let's write this as g of x equals to minus x minus 3 squared minus 1. Sure. And then this one, they say find the equation of h of the curve with the equation y equals to x squared after it has been transformed by a sequence of transformation t followed by r. So remember, t was 3 and minus 1, right? This is right. And then this is down. So we start by t, okay? So by t, we have going to have h of x. We have to move this 3 units to the right, okay? So x, remember, to the right will minus, and then down. And then now when we perform r, we're going to make everything negative there. So we switch the signs on each term. R is negative h of x, basically. Right? Which becomes, we can take this negative that side. So basically we have this. We have h of x is negative x minus 3 squared plus 1. So in simple terms, reflection in the x-axis, you're just going to switch the signs of each term, right? You are making the function negative, basically. Awesome. Let's move on, ladies and gentlemen. Let's move on. Let's move on. Now they say, state fully the transformation that maps the curve of g of x onto the curve h of x. So the question is asking us, how should we transform g to become h? Okay. So obviously, you need to check how similar they are. If you check, let's use a highlighter. Né? If you check this part and this part on both g and h is exactly the same, so no need to move either left or right, right? Because those are exactly the same. No need to reflect because they are exactly the same. But the difference is here. Here is minus 1. Here is plus 1. How can we move minus 1 to make it plus 1? Obviously, we need to add 2 there. So it means we need to move this graph 2 units up and 0 unit to the left or right. And that's the answer for this question. So here the answer will be 0 unit left or right, 2 units up. Remember, positive means up. Then that is the final answer for this question. Sure that makes sense, ladies and gentlemen. If you are following so far, please don't forget to subscribe the channel. More fire content is coming. Okay, awesome. So we are now on question 5. All right. So on question 5, they want us, let me use the blue color. Show the equation. This can be expressed as this, where this, that, and that are integers to be found. Okay, so basically they want us to find the value of A, B, and C. All right, awesome. So that should be easy. You have 4 sine x. Remember, guys, tan x is basically sine x over cos x. And then which means this is tan over 1, right? Which means if I were to inverse, this is going to be 1 over tan is the same as cos x over sine x. All right. And then with that given, in this case here, you can see that, okay, here I have plus 5 multiplied by 1 over tan x, right? Remember, if it's at the bottom, it means I can introduce a 1 here. So it's 5 multiplied by 1 over tan x, which give us this guy here, cos x over sine x. So cos x over sine x plus 2 over sine x equals to 0. And then we can see that, okay, this is over 1. And then we can see that, okay, LCD here, it's, okay, let me just put this over 1 as well. LCD is sine x. So I need to multiply by sine x here, so that this is sine x. So multiply by sine x over sine x. Okay, here I'm not going to multiply by anything because it's 0. 0 multiplied by anything will always be 0. So I have 4 sine x times sine x, which is 4 sine squared x plus 5 cos x plus 2 equals to 0. This part I'm not multiplying by anything similar to that one because they're already under the denominator. All right. Awesome. So now let's check what we have obtained so far with relative to what we are trying to find. So here, the only issue is here. We have cos squared x, but here we have sine squared x. But fortunately, or happily, or excitingly, there's a formula that links this and that, right? Which is sine squared x plus cos squared x equals to 1. The Pythagorean identity, which means if I need to replace the sine squared x, I can write it as 1 minus cos squared x. I just move this that side. So which means here I basically have 4, 1 minus cos squared x. I replace the sine squared x with this, then the rest stays the same. And then we have 4 minus 4 cos squared x plus 5 cos x plus 2 equals to 0. And then we have minus 4 cos squared x plus 5 cos x. This one and that one will give us 6, right? Plus 6 equals to 0. Guys, I always prefer to leave and this is the advice I also give you, ne? Leave the square part as positive. So I'm going to switch all the signs. This was negative, it becomes positive. This will be negative equals to 0. And now you can see that you have a, which is 4. So a equals to 4. Then you have cos squared x plus b, which is minus 5. And then cos x, and then you have plus c, which is minus 6. You see? And that is finito. Okay. Now they say hence. Remember, if a question says hence, as I said earlier, it means use whatever you have above to answer this. So now, we got this as our answer previously, right? And then we need to solve for this for 0 to 360. So this should be easy, ladies and gentlemen. We know that this guy is exactly the same as that guy because we proved it, right? That's why they said hence. So you have 4 cos squared x minus 5 cos x minus 6 equals to 0, because this and that are the same, right? But this is a trinomial, ladies and gentlemen. If you want to see it nicely, you can do this. You can say, let cos x equals to k. So you can see that here we're going to have 4k squared minus 5k minus 6 equals to 0, right? But I'll still use it this way, né? Because remember here it's cos squared, so it's k times k, so it's that k squared, right? This k there and then minus 6. Yeah, but let's factorize this trinomial. So we're going to have 4 cos x, then you have cos x, and then you're going to have plus 3 minus 2, right? And then I always verify if I'm fine. This and that gives me 3 cos x. That and that gives me minus 8 cos x. When I add them together, positive 3 minus 8 gives me minus 5. So I know I'm fine. Okay, awesome. So now we can proceed. We can now move on. Let's see. So this guy here will be 4 cos x plus 3 equals to 0, or cos x minus 2 equals to 0. Cos x is not, okay, this one you're going to say is not, né? Is not equals to 2. Remember, cos x and sin x can only be 0 point something or negative 0 point something. Anything bigger than that or smaller than that is not true. So we are left with this guy only. So you have cos x equals to negative 3. You move the 3 that side and then you divide by 4. All right. Perfect. And then, because cos is negative, I know that my solution lies in the second and the third quadrant. Right. And then if you remember, in the second quadrant, it's 180 minus, right? The third quadrant, it's 180 plus. Plus what? Let's get the reference angle. So ref angle is going to be, remember, you're going to say x, which is your angle, is the same as shift or arc cos. When you do reference angle, ladies and gentlemen, you avoid the sign. The reference angle is always positive. It's in the first quadrant. Right, so even if that was negative, when you do reference angle, always make it a positive. And when we press that on our calculator, it gives us 41.4 degrees. Remember, you always round off to 1 decimal places for angles. Right? And then, therefore, you can see that if you say 180 minus this, you are going to get how much? You are going to get 2. No, that one is if I plus with this one. Let me see on a calculator. Yes, so this is 221.4 degrees, or if I minus, is going to be 138.6. Right, degrees. And those are the two solutions, ladies and gentlemen. And that's it with this question. Let's keep on going. Let's keep on going. Next one. Awesome. So this question, they say in the diagram, shows a motif formed by a major arc A, B, C. Okay, let me just come down a little bit. Wait, what is happening here? Too much zoom. Sorry about that, ladies and gents. Let me adjust this. Yeah, this should be fine. Okay. So here we are asked, okay, let's see. Let's see this. So they say the diagram, that what is happening? The diagram shows a motif formed by measure arc AB. Okay, the measure arc AB is that one. So this is the motif, okay, formed by the measure arc A and B, okay, of a circle with radius R and a center O. Right. So the circle with radius R. So this is the center of the circle. Okay. And then this is the radius of the circle. Sharp. So I like to just show all the radiuses. Ne? So that is also a radius there. Sharp. Awesome. We'll need another part. Let's remove that. Sharp. Awesome, because it's from the center to the circumference as well. Ne? So that is an R. Small r there. And then the minor arc AOB, which is this one, of a circle also with radius R, but with center C. Oh, so there's another circle AOB here. Ne? And then that circle AOB also has the same radius as this circle, the big one, but with center C. So the other circle, its center is here, right? And then this arc is for that one, which means the length from here to this is the center of the smaller circle, and this is on the circumference. So that is R, because the set is the same length, right? I just needed to redraw this part here. Doesn't look nice. Okay, so let's see. Doesn't want to do shapes properly. Let's see. Okay, I think I'll just leave it like that. Let me try last one time over here. Awesome. So that's R. And then obviously from here, this is the center that is on the circumference of the smaller one. So that will also be R, right? Sharp. Awesome. So now we are sorted here. Here we have equilateral triangle, and also here I have equilateral triangle. So remember, equilateral triangle, all the angles inside are 60. So remember, pi is 180. So basically it's pi over 3. Pi over 3. All of the angles are pi over 3, right? Pi over 3. Pi over 3. Pi over 3. Remember, pi is 180. So you always think of pi as 180. So if you need 60, you say 180 divided by 3 is 60. So it's pi over 3. Sure. So I've analyzed. The point C lies on the circle with center O. Oh, so point C lies on the circle with center O, which means this basically is the whole circle. That's what they're telling us. Ne? This forms the whole circle. And there's an interesting thing here that we need to acknowledge. Ne? Is this. This part, it's exactly the same as this part. It's like if I were to flip this to there, it will get exactly on top of C. That is very important to note. Okay. So now, let's see what they need now. They say given that angle ACB, where's ACB? ACB. ACB is this angle here. So ACB, we know that it's pi over 3 plus pi over 3, right? Then they say equals to kx. I mean k pi. And then this is 2 pi over 3 equals to k pi. I'm sure we can see that the pi's are going to cancel each other. So we have k equals to 2/3. Right. That is what they wanted to us to get there, the value of k. They say state the perimeter of the shaded motif. Remember, the perimeter of a circle is just its circumference, right? And because this part here is exactly the same as this part, we are just basically looking for the perimeter of this circle, right? Because the perimeter of the shaded motif, this line here will be replaced by that line because they're exactly the same. So we're just looking for the perimeter of a circle, which is, let's go and write it down. The perimeter of a circle is 2 pi r, right? So you're going to say perimeter equals to 2 pi r. And that's it. Let's go to the next question. The next question, what do they want? They want us to find the area of the shaded motif for 5 marks in terms of pi r and square root of 3. Okay, I'm going to solve this up there, guys, because it's very down. So I'll try to solve it somewhere here. Sure. So let's see if blue is visible here. Yeah, it's visible. Okay, so here they need the area of this part. I'll call it A1. Sure. So to get A1, we are basically going to look for the area of the entire circle, which is A, let's say A circle, we can say big circle, minus the area of AOBC, right? AOBC, we need to minus that. AOBC, which is like an ellipse, ne? Awesome. So area of a circle is easy, it's pi r squared, but the area of this guy here, we need to be strategic. Ne? Sure. Firstly, we need to acknowledge that since this is this part here is exactly the same as that part, it means this part here, you see this part that I'm shading, is going to be exactly the same as this part here. They're exactly the same. Right. So I can basically work with this part. I'll show you something now. Let me remove the highlights. So here I have this. I can find this area here. Right. I can find that area, which is the area of a sector, right? And then, but here I have 4 sectors. I have this sector. Okay, I'm going to use different colors. Let's use red for the other sector. And all these sectors are equal in length. Ne? This one. And then I have, let's get another one. Let me get a different color. I have this sector. This one in purple. And then I also have this sector. We can name it in blue. Ne? This one. All these 4 sectors are equal. So I'm going to get the area of 1 and just multiply it by 4, right? But I'll show you something there. We need to be careful. This guy here, the area of this triangle is calculated twice for the red and the orange. So I'll need to minus this area. And I'll also need to minus it here again, right? Sure. So now let's do that. Remember, the formula of the area of a sector is basically half right? Half theta r squared. But because I have four sectors that are the same, I'll say multiply by 4, right? Then remember I said I need to minus the area of this triangle because it's the red and the orange including it. You see, when you come here and when you go there, and also this one, I need to take it out because they are double counted and they are exactly the same in length. So I'll say, okay, we also need to minus the 2 times the area of the triangle, right? Which we are going to use area rule. Ne? Awesome. Now we are sorted. We can now just solve. We have done the important part of this question. So you're going to have pi r squared minus half. Remember your angle is pi over 3, which is there, right? And then your r squared will just be your r squared times 4, right? Let's get more color. Sharp. Then minus 2 is too big, that one. Let's put it to 3. And then remember the area rule says it's half the first side, which is this one. I'll say half r, half times r, times the second side. So I'm using this side and that side, times r, and the angle in between them, which is that. So sine of pi over 3. Now we can simplify. So we're going to have pi r squared. If you check here, you're going to have negative half times 4, which gives you negative 2. So you're going to have negative 2 pi. The r squared will just be there. The 3 will just be there. All right? And then here, negative 2 and the 2 will cancel. So you're left with minus r times r, it's r squared. Sine 60, remember this is 60, right? 180 divided by 360. We know that sine 60 is square root of 3 over 2. All right. And then what does this simplify to? Let's see. These two here are like terms, guys, because you have pi r squared, pi r squared. This one is an unlike term, so this one will stay alone. But these are like terms, so I'm going to do LCD for these two. Ne? So here I'm going to multiply by 3 and there by 3. So I have 3 pi r squared minus 2 pi r squared all over 3 minus square root 3 r squared over 2. Then here you can see that 3 minus 2 is just pi r squared, right? So basically here we have pi r squared over 3. And that is finito with this question, ladies and gentlemen. We wrote it in terms of pi r squared and square root of 3. Thank you very much. Yeah, that was a little bit a hectic question. It was a high order question. Yeah, but if you practice, you'll get used to how to analyze these things, right? So we just answered that. Now we can move on to the next one. So let's go to the next one. Okay, we have a blank page here. Let me just move quickly. Okay. Awesome. So now we are here. Let's see what they want here. They say, okay, the sum of the first two terms of geometric progression. Okay, so T1 plus T2, right? For geometric progression is 15. It's 15. Sharp. Remember, the first term for geometric is A. And then to get the next term, you just multiply A by R, right? So you get AR. Then they say the answer is 15. I'm going to make A the subject of the formula. So I'm going to take A out as a common factor. Here I'm left with 1 plus R equals to 15. Then A remains alone if I divide by 1 plus R both sides. So here I have 1 plus R. And I'll call this my first equation, ladies and gentlemen. Right. And then we are now going to keep on reading. They say the sum to infinity is that. Remember, the formula for the sum to infinity is A over 1 minus R. That is the sum to infinity. And then they're telling us the value of the sum to infinity is that. All right. Let's also make A the subject of the formula here. Quickly. So I'm just going to multiply both sides by 1 minus R. 1 minus R. So A is the same as 125 in bracket 1 minus R over 7. That is equation 2. All right. And then they say their common ratio, which is your R of the progression, is negative. So we know that R is less than 0. Find the third term of the progression. Okay. So we have done most of the parts already. We know that the first equation and the second equation are equal. So equation 1 equals to equation 2. All right. Because they are all equals to A. You see? That is A. That is A. So we can say, okay, using that fact, we are basically having 15 over 1 plus R is equals to 125 over 1 minus R over 1 minus R all over 7, right? Now we need to cross multiply here basically, right? Doing the LCD. Awesome. So to cross multiply, we're going to say 7 times 15. 7 times 15, it's 105. So let's see, 105 is equals to 125. Here we have 1 minus R, and then you're going to multiply with 1 plus R. Right. So you're going to divide 105 by 125. Let's see, 105 divided by 125. That gives us, let's see, 50. Yes, and then we're going to say 105 divided by 125. That gives us 21 over 25. After dividing this one, and that one. All right. Sure. So this side, we are left with this part, which is difference of two squares, which is 1 minus R squared, basically. When you FOIL it out or multiply it, you are going to get that. Right. Now, guys, I'm going to swap them around. The negative R squared, I'm going to bring it this side. So I have negative R squared. This one, I'm going to take it that side, which is 1 minus 21 over 25. So R squared is equals to 4 over 25. Right? And then, therefore, we can see that if we square root both sides, we're going to have plus minus 2 over 5. All right. And then, because they said R is greater than 0, we're going to say, therefore, we're going to only use R equals to, or they said less than 0, sorry, negative 2 over 5. Right. So that's your R. Then if you remember well, one of your A's was, let me think, it was, let's check, ladies and gents, let's check to avoid errors. If you're not sure about it, it's 15 over 1 plus r. Ne? Yes, I'm taking the easier one, which is this one. Sharp. So let's do that. So we're going to have 15 over 1 minus 2 over 5, which give us 4. Therefore, term number, remember we know that for geometric, the Tn equals to AR to the power n minus 1, right? Then you can say, okay, therefore, we're looking for the third term. The third term is going to be, the first term is 4. So we put 4 there. Our r is negative 2 over 5. Our n is 3 because we're looking for the third term minus 1. What does that give us? Oh, guys, actually here I miscalculated. Ne? This is, let's see, 15 over 1 minus 2 over 5. That is 25. So A is 25. Okay. Sorry about that. And then the 4 comes in. Thank you very much, ladies and gentlemen. Let's keep on going. Let's keep on going. Let's keep on going. Okay. We are now on question 8. Okay. So on question 8, I have 2 graphs here, and then I'm having a shaded area. Obviously, I know I'll be doing integrals here, right? So this is the graph on top. I'll just put it blue. Awesome. And then I'll just highlight that like that so that I can see the difference. Okay, sharp. So now we're going to do this, ladies and gentlemen. The diagram shows the curves with equations, this and that, meeting at points A and B. So they're meeting there, right? Obviously, those are point of intersections, which is where the 2 graphs are the same. By using the U substitution of that, find by calculation the coordinates of A and B. Right. So they say U is this basically. Where I see this, I see U. So here is like I have 2U to the 4. And then this one, because we're looking for point of intersection, I'm going to say equals to. So we're going to say equals to U squared plus 1. U squared plus 1. Sharp. And then we're going to have this now. We're going to have 2U to the 4 minus U squared minus 1 equals to 0. So I just move everything that side. Now this is a nice trinomial there. We can factorize this, which is 2U squared, right? Then this side you have U squared. Then you're going to have plus 1 minus 1, which equals to 0. All right? And then we're going to do this. We're going to have a 2U squared equals to negative 1, or U squared equals to 1. All right? And then we're going to substitute a U back now. But before we do that, let's do this. This guy here is not true, so we're going to say not equals to y, because whatever U value we put, we're always going to have a positive. So this part will never be negative. So here we can do a square root. We can do this. 2x minus 3 squared equals to 1. All right. So now let's see. We can square root both sides. When we square root both sides, this side we're left with 2x minus 3. That side we're going to have plus minus 1. Then we need to split now. So you have 2x minus 3 equals to plus 1, or 2x minus 3 equals to negative 1. Then you can see that here is going to be 1 plus 3, which is 4 divided by 2. So x is 2. Or here you're going to have minus 1 plus 3, which is 2, then divided by 2. So x equals to 1. All right. And then now I'm going to substitute the 2 and the 1 into the easier one. So I'll use this one. You can even use that one on your calculator, it's fine. Okay, let's use this one. So we're going to replace this by 2. So we're looking for f at 2, or let's say y. Ne? So it's going to be 2 in bracket 2, and then 2 minus 3 to the power 4. I'm sure you can all see that this is 1 to the power 4, which is just 2. So your first point will be 2 coordinate 2, right? And then if we were to put 1, let's see, or y equals to 2, 2, 2, I mean 1 now, sorry, minus 3, 4. This is also yielding y equals to 2. So when x is 1, the y value is 2. And then this is the smaller point because the x is on the left, this one, the x is on the right. So we're going to check which one is which. So by the look of things, you can see that, okay, A is the first one. A is the first one. And B is the second one. Okay. So the bigger one is B, the smaller one is A. And we have found this, ladies and gentlemen. We're going to move to the next part now. Okay. So the next question wants us to determine the exact area of the shaded region, right? So that shouldn't be an issue. So obviously we need to take the graph on top, which is this one, and then we're going to minus with that one under the integral, right? And then the region is between 1 and 2. So the lower limit is 1, the upper limit is 2. Because the x value here is 1, the x value there is 2. We just proved it here, right? Awesome. So now we can proceed. So remember, I said we're going to use this formula. Area, or the exact area, is basically the integral, right? The integral, I didn't write that sign properly. Let's write it nicely. So the integral between 2 and 1, remember the lower limit is 1, the upper limit is 2, of the graph above, which is 2x minus 3 squared plus 1. And then we need to minus the graph below, right, which is 2x minus 3 to the power 4 dx. That is the exact area. All right. Now let us simplify that and see what it simplifies to. So I'm going to do this like this. We're going to look for the integral between 2 and 1 of 2x minus 3 squared plus the integral of 1 from 1 to 2. Sorry, this one must have dx here, then dx, and then minus integral of 2x minus 3 to the power 4 dx. All right. Then let's see what does that give us. We are going to have okay. So here, guys, when we do integration, remember, and we have brackets, we need the derivative of this to be here. So the derivative, but we don't have it, so we're going to introduce it. The derivative of 2x minus 3 is just 2, right? It's just this part. So it gives you 2. But because we're introducing a 2 here, we have to counteract it with a half outside. So this 2 will cancel with that 2 if we're to multiply them together. You do that so that you are not changing the meaning of the equation. Right. This one is a constant, the derivative of constant. I can do this here to make things simple. Can introduce x to the power 0 there. Right. Now here, the derivative of this is there. So here we don't need to introduce anything because the derivative of the bracket inside of the bracket, it's outside. So we're fine. Right. And then now we're going to have this, ladies and gentlemen. The half is still outside. Now we're integrating. Remember when you integrate, you add there. So you basically have 2x minus 3, 2 plus 1. Remember when you derive, you minus. So when you integrate, you add. So you add 3 and then you divide by 3. Ne? You don't multiply by 3. This is integration. All right. And then the outside just goes away. Ne? You ignore it. And then you still keep your limits there. The derivative here is 0 plus 1. Here there's a plus there. And then 0 plus 1 is x to the power 1 divided by 1, which is just x. Then 2, 1. And then here you have minus. Is going to be 2x minus 3. Remember, when you add there, you get 5 all over 5. Then the limit is 2 and 1, right? And then you have a half. Now we need to substitute. No? So if you check here, there's a 1 here. So I have 1 over 3. If I substitute, you always start by the upper limit, no? Minus the lower limit. So if you substitute 2 here, you're going to get 2 times 2, which is 4, minus 3, which is 1 cubed, which is just 1. And then we're going to minus that by 1 over 3. And then here, if we substitute 1 now, you get negative 1. Right. And then plus, this one is simple. This is 2 minus 1. Right. And then here we're going to have, remember there's a 1 here, so you have 1 over 5. And then what do we get when we substitute 2 here? We get 1 minus 1 over 5. If you substitute 1 there, this part here will give you negative 1. And then pressing everything on a calculator gives us 14 over 15, ladies and gentlemen, which is true. Right, which is the area under the curve. I think we're done with this question now. Can go to the next questions, ladies and gentlemen. I'm going to just erase this part to create space. Okay, so this question here, they say express this part in the form there, where a and b are constants. Okay, sharp. So that is fine. So guys, here I can see that, okay, this is basically 2x plus a, 2x plus a plus b, right? And then this we can see is a perfect square trinomial. So I'm going to write this in such a way that we have a perfect square trinomial. A perfect square trinomial says the first part must be perfect square, which is correct, minus 12x. And then I'm going to break this in such a way that I take out a perfect square, which is plus 9 in this case, and then plus 4. So the 13, you break it to 9 plus 4. Ne? And then now you can have that. So 2x minus 3 2x minus 3 plus 4. Then this is minus 6x minus 6x, which gives you the middle. So you know you factorize properly. So it's 2x minus 3 squared plus 4. Then that is finito. We can go to the next part of this thing. Okay. So if you check, they say the function f is defined by this. So f is basically also this, right? From there. Remember, this guy is exactly the same as that guy. So we're going to say 2x minus 3 squared plus 4. So there. Right. For pxq, so they give us the domain of this function where pq are constants. The graph G is defined by that, where the domain is x is less than 8. Okay, sharp. So now, what is the question? Given that it is possible to form a composite function GF. Okay. So guys, we are going to have a composite function only and only if this is true. Yeah? Okay, let me draw an interval to show you what I mean. So this is P, that's Q. And then we have this one. So the next one is 8 here. Yeah? So the composite function is only going to exist here, where both the domains intersect. Yeah? So where the domain of this function intersect with the domain of that one. That is the only part we're going to have. The composite function, yes. So they say, given that it is possible to form a composite function, find the least possible value of P and the greatest possible value of Q. Okay. So we're looking for this P and this Q that will be on this interval. Sharp, because this one will keep on going forever. Right. So immediately we pass this value, is no longer possible to do composite here. And also there is not possible. You see? Sharp. So we're just interested where the composite can fall. Okay. So I'm interested also where this graph is less than 8. Okay. 2x minus 3 x squared plus 4 must also be less than 8. Then we have 2x minus 3 squared. This you go that side, you have 4. All right. And then here you have 2x minus 3. Then minus 4 is less than 0. Here you have a difference of 2 squares, which is 2x minus 3 in the first bracket, and then 2x minus 3 in the second bracket. Remember, it's always plus minus 2 and 2, which is less than 0. So you have 2x. This one gives you -1. And then this side you have 2x minus 5. So see this, you can see that your critical values here is going to be 1/2, or x equals to this side is going to be 5/2, right? Because basically you can say x minus 5 equals to 0. Then x equals to, take the 5 that side and then you divide by the 2. Sharp. Now we need, remember, this is a parabola, right? So here you have half, here you have 5/2. And you are looking for less than 0. Less than 0 is from here to there. It's where the graph is negative. It's at the bottom, right? So we can see that, okay, these are meeting. So x is in between. X is in between half and 5/2. Therefore, the smallest value of P will be this one. Do you see it? They said the least value of P will be half. And then the greatest or highest value of Q will be 5/2. And that's finito with this question. Right. Now let's go to the next part. The next part, they want us to get the composite G f of x. So it's like we substitute, remember G of x is basically 3x plus 1, sorry, plus 1. So what we do here, and then f of x is basically 4x squared minus 12x plus 13. So basically we take this, it becomes our x, we put it there. So this will be 4x squared minus 12x plus 13. Then there's plus 1 there. Sharp. So you basically write this, but this you replace with that. This gives us 12x squared minus 36x plus 39 plus 1, which is plus 40. And that is your composite G, composite F. And that's it, ladies and gentlemen. Now, they want us to determine the expression of the inverse. So they give us H to be that, and then they need the inverse, okay? Sure. So remember, to get the inverse, we just replace everything by switching them around. So the x becomes the y becomes the x. So I'll just say this here. Then to show that I'm doing the inverse, this is the y, it becomes the x. This is the x, it becomes the y. This is the x, becomes the y. So y is less than 0. Right? But if we check, this is exactly the same as what we have been working with. So we can actually write this as 2y minus 3 squared plus 4. Right? This completing the square basically here. But we already did previously. Remember, the answer was this, right? Sharp. I just replace the y with the x. Sharp. And then I replace this with the x, that with the y. Sharp. So now we need to make the y the subject of the formula. So we take this that side. So you're going to have x minus 4 equals to 2y minus 3 squared. Then I'm square rooting both sides. So this side I'm going to have x minus 4 plus minus, right? Then this side I'm left with 2y minus 3. Then I'm taking the 3, that side, which becomes 3 plus minus x minus 4 equals to y. I'm going to divide both sides by 2. So the 2 that was here is there now because I'm dividing both sides by 2. Right. And then we need the y. Remember, y is greater than 0, right? Y can only be positive. So the negative part must go away here. So we're going to have 3 plus x minus 4 over 2 is equals to y. And that's finito. We can now go to the next question. Let me just erase this to create space. So here they say, okay, a curve has a stationary point 2 and negative 10. And is such that its second derivative is 6x. Okay. So they need the first derivative. Okay, that's fine. So the first derivative will be the integral of the second derivative. If we integrate the second derivative, we get the first. So these are opposites, guys. The derivative of the first derivative is the second derivative. The integral of the second derivative is the first derivative. It's like you're doing the reverse, ne? Sure. So now we have that, and then, but we know that the second derivative is 6x, and then that is dx. Then here, remember, if I integrate, this is 1, so I'm going to add. So I'm going to have x squared over 2, not 6. But there was a 6 there already, plus c, right? Remember, if it's an indefinite integral, you put c. Then this is 3x squared plus c. And this is dx over dy. But they said the stationary point, remember on stationary point, dx, yeah, dy over dx will be 0. The first derivative is 0 on a stationary point, right? So we know that, okay, if the x value was 2, as shown there, this derivative will be equals to 0. Therefore, we can see that c will be, this is 12, so it's negative 12. Right. Therefore, dy over dx will be the same as 3x squared minus 12. Right, and that gives you 3 points. Awesome. Now we can move on to the next part. Find the equation of the curve. So now they need y. So we're still doing the same. This is the integral of dy dx. You see, the derivative of y is dy dx. The integral of dy dx is y. So when you differentiate y, you get dy dx. When you integrate dy dx, it's like you are going back. So you get y. Awesome. Then you have y is equals to, remember the point is 2 coordinate negative 10. So we have this now. Remember the first derivative is that. Right? Which give us, here we add a 3. So you're going to have x to the 3. Then you divide 3 divided by 3 is just 1. Sharp. Then here we have x to the power 0, basically. Here we're going to have minus 12x, because the integral of a constant is a constant times x. Ne? Sharp. And then plus c. Right. So y is equals to x cubed minus 12x plus c. But we have a point, so this is our x, that is our y. So we have minus 10 equals to 2 cubed minus 12, 2 plus c. And we can see that if we were to solve this, this will be 8. This will be minus 24 plus c. Right? And then let's see what does that give us. This gives us negative 16. So that side is going to be 16 minus 10, which is 6. So c is 6. Therefore, y equals to x cubed minus 12x plus 6, because your c is 6. Right. And then let's go to the next question. They say find the coordinates of the other stationary point and determine its nature. So by saying determine its nature, they mean, is it a maxima or a minima? Ne? Is it a maxima or a minima? Okay, sure. That is fine. So we're either going to use a second derivative test or first derivative test to decide if it's a maxima or a minima. But now let's determine it. Remember, stationary point, always dy over dx equals to 0. Right? And then we know that dy dx is 3x squared minus 12 equals to 0. Then x squared equals to, you take 12 that side, then you divide it by 3, which gives you 4. So you have x squared equals to 4. And I'm sure you can see that if we were to square root there, we're going to have plus minus square root of 4, which gives us 2. Therefore, x equals to 2 or x equals to minus 2. But this one we've already been talking about it above. We're given that there's a stationary point of that, right? Which is this one. So the one that we're interested in is this one. So now we're going to say, okay, therefore, y is equals to minus 2. We substitute in minus 2 there and there. Minus 12 minus 2 plus 6, which becomes, let's see on a calculator. That gives us 22. Right. And then the point is going to be -2 coordinate 22. All right. Now I'm going to do the second derivative. I mean the first derivative test. So to do the first derivative is this. You have -2 on the turning point and 2 on the turning point, right? I need to know the signs in between. So I can pick a number here, which is 0. So if I pick 0, what do I get? I substitute on the derivative. So 3, 0 squared minus 12, we get a negative. So in between, we get a negative. I can pick a number here, 3, for example. If I put a 3 here, we're going to end up with a positive. Also, if I put a -3, we end up with a positive. Right. And then I can see that, okay, on this one, the graph is positive, so it increases. Then this side, it decreases. Then here, it increases. Remember, when the gradient is positive, it means increase. So you can see that your curve is facing like this, right? So obviously, this is the highest point. The graph is concave down. So this is maximum. I can prove to you with the second derivative. Remember, we're given this. We're given that d squared y over dx squared is 6x. Let's substitute -2. 6 minus 2 gives us -12, which is less than 0. Therefore, concave down, right? Concave down. Concave down means your graph is facing like this there. So you're going to have a maximum. So this is local. Just say local, local maxima. Maxima. Sharp. And now they need us to do what? They need us to find the tangent. They say, find the equation of the tangent to the curve at the point where the graph crosses the y-axis. So the graph crosses the y-axis at this point. 0 coordinate 6. Remember, this is your y-intercept, right? So now we need to get the gradient. Remember, the gradient is the first derivative, né? Which is basic. What was the first derivative again? Let's go check that. So the first derivative was 3x squared minus 12, right? But we're looking for the first derivative when the x value is 0. So it's there, which is that. Therefore, you have y equals to, your m is -12, x, your c is the y-intercept plus 6. And that is it with that question, ladies and gentlemen. All right. Awesome. So now we're doing the last part of the question paper. The last part of the question paper. I'm just going to put my center here because they didn't give it to me so that I can conceptualize this. like that. Okay, sharp. I know that, okay, I'm gonna call the center M, ne? Sharp. Then I know that my center, by the look of things there, is basically 4 coordinate -1. And I know that this is perpendicular, radius perpendicular, diameter or tangent, right? Yeah, radius perpendicular, tangent. Also, this will be perpendicular then. And they say the diagram shows the circle with equation, blah. Parallel tangents. So the tangents are parallel, has gradient of 1. So M here equals to 1. And also M here will be 1. So since the lines are perpendicular, the M here will be -1. Okay, sure. Now they say find the equation of the line AB, giving the answer in the form. Okay, we are sorted. We know that the center is 4 coordinate -1. We have a point. And then M of AB times M of tangent. Just show how you got it. Ne? You must get -1. All right. Awesome. And then because how did I, because someone might argue, how did you know that this is the diameter? Because they told me these lines are parallel. That can only happen only and only if they are exactly on the center of each other. Ne? So that only happens on the diameter. For example, if I have a circle here like this, and I have this part, which is a line, and this line here, they can't be parallel if they are not passing through. You see the diameter is there, it's like a little bit like that. So if I'm told this parallel, it means that AB is basically the diameter. Sharp. Because AB perpendicular, okay, you can say tan perpendicular diameter. Sharp. And then you can see that, okay, therefore the M of AB is -1 because this one is 1. 1 times -1 will give you -1. Remember, the product of the gradients of the lines which are parallel is -1. And then now you have, therefore, y equals to -1x plus c. Right? And then this gives us y. Okay, so we have a point, right? So then y is -1, x is 4 plus c. This gives us -4. When I take it outside, I get 3. So c equals to 3. Therefore, y equals to minus x plus 3. And that's it, ladies and gentlemen. Now they say, next question, they want us to do what? Find the coordinates of A, each in a sub form. Okay. So each coordinate must be in the sub form. Okay. Sure. So to get the coordinate of A, I'm going to do this. To get the coordinate of A, remember the coordinate of A and B is the point of intersection between the circle and this line, right? Sharp. So I'm just going to find A and B. But I know that A is the smaller, is the one with the smaller x value because it's on the left. Okay. Sharp. So let's write the equation of the circle and the equation of the line. So the equation of the circle is x, okay, minus 4 squared plus minus, is going to be x, sorry, is going to be plus y plus 1 squared equals to 40. Let's just verify if I copied it properly because I'm just saying it. x minus 4 squared, y plus 1 squared equals to 40. Okay, that's correct. And then the tangent, I'll say, and the tangent was minus x plus 3. Because we're looking for the point of intersection, I'm going to substitute the y there. So you have x minus 4 squared plus minus x plus 3 plus 1. Right, this is the y, but there was a plus 1 already. Squared equals to 40. Right, and then this one here I can just say plus 4 basically. Awesome. And then now let's FOIL this. Let's FOIL this. So here we're going to have x squared. This times that is minus 8x. This times this is plus 16. This times that it's plus x squared. This times that it's minus 8x. It's plus 16 equals to 40. All right. And then we can see that, okay, here basically we get x squared with a 2, because these are like terms, minus 16x, this one and that one, plus 32 equals to 40. And then we can see that there's a common factor of 2. So I'm going to divide everything by 2. And then this side I have a perfect square trinomial, which is easy. It's x minus 4 squared equals to 20. And then we need to square root both sides. We need to square root both sides. If I square root both sides, this side I'm left with x minus 4. That side I'm having plus. Remember, when you square root, you always have a plus minus. Square root of 20, it's 5 root 2. No, I'm wrong. It's not 5 root 2. It's going to be 2 root 5. I did it vice versa. No? It's 2 root 5. 2 root 5. Because this is 4 when it's inside, yes. Perfect. But because we said we're going to take the smallest x value, the smallest one is the one with a minus here. So we're going to say, therefore, x equals to minus 2 root 5 plus 4, which can be written as this, 4 minus 2 root 5. All right. And then now we take this, we substitute. Remember, this is the x on A. To get the y on A, we're going to substitute there. So you're going to have y, minus the x is 4, minus 2 root 5. All right, plus 3, which gives you minus 4 plus 3, which is minus 1, plus this one will just be plus 2 root 5. Then the coordinate of A will be 4 minus 2 root 5, which is the x value. Then this one, I'll just write it this way, 2 root 5 minus 1. And that is it. Now let's do the last part of this question paper, I think. Yeah, this is the last part of this question paper. Okay, so they say, find the equation of the tangent at A. So at A, remember, we have a point, which is this, and then we know that the gradient is 1, right? Sure. It told us that the gradient at A is 1. So y equals to 1x plus c. Then you can substitute that. The y value is 2 root 5 minus 1 equals to, here is just x basically. So 4 minus 2 root 5 plus c. And then now, what are we going to have? we're going to move everything that side. So 2 root 5 plus 2 root 5 will give us 4 root 5. Then this one and that one will give us minus 5 equals to C. Therefore, y equals to x plus 4, which is our C, 4 root 5 minus 5. And that is finito with this paper, ladies and gentlemen. I'll keep on solving more papers. If you found this helpful, please leave a comment, share, and subscribe with family and friends. And don't forget to keep on looking for more, to switch on the notification bell so that when I upload more, it can notify you. Thank you very much. Tango. Aluta continua.